All right, today's video is going to be on solving equations, but more specifically, equations that involve multiplication and division. So here you see your first example where it reads, solve W over 4. Keep in mind this line right here. That line right in there means to divide, right? So that really says solve W divided by 4 equals 12. Notice what they're doing to both sides in the equation. They are undoing this division. And the reason why they are undoing the division, they are using multiplication. Remember, the dot there means multiplication, and they're multiplying both sides of the equal sign, the left side of the equal sign by 4, and the right side of the equal sign by 4. And this is called, of course, the multiplication property of equality. And so you end up getting a solution of W equals 48. And the coolest thing about the math is you can always check it. So you substitute in the 48 right where the W is. And so now you're seeing 48 over 4. Well, remember 48 over 4 means 48 divided by 4. And 48 divided by 4 is in fact 12. So you know you are correct. And the solution for that equation is W equals 48. All right, on to some problems now to practice on our own. Here's the first one. Solve A over 8 equals 6. Remember, though, A over 8, keep in mind that means to divide. And what is the inverse operation of division? It is multiplication. So I'm going to write it like this. A over 8 is supposed to be equal to 6, but I'm going to multiply both sides by 8. Remember, stuff squished next to parentheses means multiplication. So now if you were actually to multiply this, it would be 8 times A. Well, 8 times A would be 8A. And then, of course, you have the A on the bottom there in the denominator position. So you're staring at 8 over 8. Well, 8 over 8 is 1. Then you have 1A. Well, 1A is simply just A. That's why we multiply by 8, because it undoes dividing by 8. So then all that's left now is to do the 6 times the 8 on the right side, which is 48. And now we can check to see if this is correct by taking out the A in the equation and plugging in 48. Now, what is 48 divided by 8? Is that 6? Yes, it is. So we know we're correct that the solution is 48. On into a more challenging problem. You have 14 is supposed to be equal to 2y over 5. Now, 2y over 5. That really means 2 times the y, but then dividing it by 5. So here's a little trick. We are going to multiply by the reciprocal. And remember, reciprocal is a fraction that gets flipped. And I'm going to show you why it works. We're going to multiply both sides by 5 halves. And the reason why I'm multiplying both sides by 5 halves is because that's the reciprocal of 2 over 5. You see the 2 and the 5 there? Well, if we flip 2 over 5, the reciprocal is 5 halves. And the reason why we're doing this, I'm going to draw this out. We're doing 5 times 2y, and then we're doing 2 times 5. When we multiply that, you go straight across. So 5 times 2y is 10y, and then 2 times 5 is 10. Well, now you see 10 over 10. What is 10 over 10? 10 over 10 is 1. And then you have 1y. Well, 1y is simply just y. That's why we do that. We get rid of the 2/5. Okay, it kind of undoes itself by multiplying by the reciprocal. But what you do to the right side of the equals sign, you have to do the left side. So now we're looking at 5 over 2 times 14. Well, keep in mind, 14 is a whole number, but can easily be written as a fraction by putting 14 over 1. And then we're just going to multiply straight across. 5 times 14, I'm pretty sure is 70. We'll just double check, use the calculator here, take our time. 14 times 5, sure enough, is 70. And then, of course, 2 times 1, that's 2. Well, now you're staring at 70 over 2. Well, keep in mind 70 over 2 really means 70 divided by 2. Well, what is 70 divided by 2? I'm pretty sure that's going to be 35. Just to prove it on the calculator, there you have it. So 35 is the value for our variable y. Now we can check it to make sure we are in fact correct. The original equation was 14 and is supposed to be equal to 2 times y. Well, I said y was 35, so I'm going to plug that in, over 5. So 2 times 35, just to check it on the calculator, this is the best part. 2 times 35 is going to be 70. And then, of course, we have to divide it by 5 because all of that is over 5, which equals 14. So we know we are correct. We know that y is equal to 35. All right, try another one. Keep in mind, division sign, you can kind of substitute that in with a fraction. So you're really looking at 3z over 2 is equal to 9. And the reason why I wrote it that way is keep in mind that division can be written as a fraction. So if you can kind of see, it's 3 halves z, or 3 over 2, right? So what is the reciprocal? What is the reciprocal of 3 over 2? Well, that is 2/3. So I'm going to multiply both sides by 2/3. And of course, the reason why I'm doing this, to point this out again, you are going to be doing 2 times 3, or 2 times 3z in this case, which gives you 6z. And then on the denominators, you have 3 times 2. Well, 3 times 2 is 6. Now look what you see. You see 6 over 6. What is 6 over 6? That's 1 whole. So now you have 1 whole z. Well, how do you write 1z? You just write a z. So now what we do to the left side, we got to do to the right side. So here we have 2/3 times 9. Well, 2/3 times 9 is actually written out by times 9 over 1. Okay, 9 times 2, 18. 3 times 1 is 3. And now you're staring at 18 divided by 3. And I know 18 divided by 3 is 6. So I am saying the solution is z equals 6. Now we can check it. I'm going to check the math. So now I'm going to do 3 times my z. Well, I'm claiming z is equal to 6. So I'm putting in a 6. And then, of course, divided by 2 has to equal 9. So 3 times 6, I know that's 18. What's 18 divided by 2? I know that's 9, which means I know I'm correct. The solution is z equals 6. On into another one. Notice this one is involving multiplication. P times 3 is supposed to be equal to 18. Remember, we always solve equations by using the inverse operation. I know a lot of you can figure this out in your head, but that is not the goal here. The goal is to use the inverse operation. The inverse operation of multiplication is division. So we are going to divide both sides by 3. And now you are staring at, yet again, 3 over 3, and 3 over 3 is 1. Then you have 1 times p. Well, 1 times p is just going to be p. And then you have 18 over 3, and keep in mind 18 over 3 actually means 18 divided by 3, and that happens to be 6. So I am claiming that p is equal to 6. I can check that by substituting in my 6. Is 6 times 3 18? Yes, it is. All right, on into the last one. This reads 12 times q, because remember, a value squished next to a variable means multiply, right? So 12q means 12 times q is supposed to be equal to 60. Well, what operation is being done? Multiplication. And again, we are going to use the inverse operation of multiplication, which happens to be division. So we are going to divide both sides by what is next to the variable q, which is a 12. And why am I choosing 12? Because 12 over 12 is 1. Then you have 1q. Well, 1q is just a q. And the last part is 60 over 12. Well, 60 over 12 actually means 60 divided by 12, which is 5. Is Q equal to 5 correct? I don't know. Let's test it. 12 times Q, well, we know we're claiming Q is 5, so we plug in a 5. Is 12 times 5 60? Let's just check it. Use the calculator. Is 12 times 5 60? Yes, it is, which means we know we're correct, and the solution is Q equals 5. So remember, when solving equations that involve multiplying and dividing, you must always use the inverse operation.